Similar question is where two masses A and B are suspended through a pulley using the string, and distance of the block A from the ground is YA and distance of the block B from the ground is YB, and the distance of the pulley from the ground is H. Here this H is fixed, while as blocks A and B moves, YA and YB are changing. Therefore, we have to write these YA and YB in terms of H. So using the equation, we can see that the left hand length of the string connecting the block A with pulley is H minus YA, and another part of the string is H minus YB. So we can write that H minus YA plus H minus YB equal to length of the string. So we can write this is 2H minus YA minus YB equal to L. To get the velocity, we have to differentiate with respect to time. On differentiating, because H is constant, the first term will be 0, minus differentiating YA with respect to t minus YB with respect to t equal to, again L is a constant because length of the string is constant, so it is also 0. This implies that minus VA minus VB equal to 0, or we can say VA equal to minus VB. It implies that magnitude of the velocities are same because masses are connected through the same string, but the directions will be different because if one block is moving upward, another block will move downward. So this is the equation number 1. Now we have to find the acceleration. To get acceleration, we differentiate the velocity with respect to time. We will get dVA by dt equal to d by dt of minus VB. So this implies that AA, this is the acceleration of the body A or block A, and minus is the term which can be taken out of the differential, so it is minus, and dV by dt, this is the acceleration of the block B, and it gives acceleration of block A equal to acceleration of the block B in terms of the magnitude because they are connecting to the same string, but directions are different. If one of the body accelerate in upward direction, then another body will accelerate into the downward direction. Fifth question is, find the force F in terms of the force constant K of the spring and the displacement Y for the case A and B. These are the two cases A and B for which we have to find this force in terms of force constant K and displacement Y, where displacement Y is shown for the mass M. We are applying the force F on the mass M is displaced vertically down by Y from the equilibrium position. In the case of figure A, we know that if mass M is stretched by Y, then spring will be stretched by Y by 2. While in case of second, for given diagram, if this mass is displaced by Y, then spring will be extended by 2Y. This we have to remember. So F dash for the case A will be equal to the spring constant, which is K, into extension, that is Y by 2. And because tensions in the string are shown T, so T plus T will be equal to F dash in equilibrium. That means tension will be equal to Ky by 4. And this tension is balanced by the force F. So we can say F equal to tension, that is equal to Ky by 4. Finally, we can write that F equal to K into Y by 4. This is the first case. In second case, F dash, that is the restoring force in the spring, will be equal to K times of the extension, this is 2Y. And this F dash is equal to the tension because string has the same tension throughout its length. So it will be equal to K into 2Y. And this force F will be equal to the tension T plus F dash and tension and F dash are same, so we can write it as 2T F dash, or we can write it as K into 4Y. So in case A, force is K into Y by 4, while in case 2, force is K into 4Y. This is the answer. Question number 6 is, 3 blocks with masses M, 2M and 3M are connected by a string as shown in the figure. After an upward force F is applied on the block M, the masses move upward with a constant velocity. Here we should be careful that velocity is constant, so acceleration will be 0, because acceleration is the rate of change of velocity. Which is the net force on the block of mass 2m, where g is the acceleration due to gravity? Because acceleration is 0, that means the net force on the block 2m should be 0 by logic. So option C is the correct option. Similarly, we can also say for other masses m and 3m that net force is 0, because all the 3 forces are moving with the constant velocity, that is acceleration is 0. Question number 7 is, the coefficient of static friction μs between the block A of mass 2 kg and the table. So the coefficient of static friction is given here 0.2. What would be the maximum mass value of the block B? This is the mass of the block B, MB, so that block do not move. The string and pulley are assumed to be smooth and massless, and G is equal to 10 meter per second square. For the rest condition, the weight of the block B, which is M2G, will be balanced by the tension in the string. So we can write T2 equal to M2 MBG. This is the equation number 1. And because the string is same, so there is also a tension T. And this tension T should be balanced by a force, which is here the frictional force. So we can write this tension T is equal to Fs. This is the static friction force, because body should be in rest. To get the maximum value of the tension, this Fs should be maximum, because Fs is less than equal to Fms. This is the maximum static friction force. Whose value is mu Sn. And here this mu Sn is, n is the A, which has the mass Ma, into G, this is the weight, and normal is n. So n equal to MAG. So we can write the maximum static friction force is mu s into Ma into G. That means T equal to mu s into Ma into G. This is the equation number 3. So using the equation number 1 and 2, we can write that MBG should equal to mu s MAG. This G get cancelled. So MB should equal to mu s MA, and mu s is given 0.2 and Ma is given 2. So mass of the MB will be 0.4 kilogram. So option D is the correct option.